Hello, this is a video lesson on 9.4 sequences. This video lesson will be a little bit different. It's coming a couple days after you've been introduced to 9.4, and I'm not really going to go through all the definitions and theorems and things like that, but I'm going to talk about and work through or start a bunch of problems like or exactly what you had assigned for your homework. So just real quickly, a sequence, one of the most natural ways to study patterns in mathematics is to look at an ordered progression of numbers called a sequence. A finite sequence has a fixed number of terms, so that means it stops at some point, and an infinite sequence has an infinite number of terms, which means it goes on forever. Some sequences have a rule that gives the kth term in the sequence, and others do not. When talking about the limit of a sequence, if we let the set a sub n be a sequence of real numbers and consider the limit as n approaches infinity for that a sub n set or rule, if the limit is a finite number, the sequence converges. And whatever it converges to, that number, is the limit of the sequence. If the limit is infinite or non-existent, then we say the sequence diverges. I'll go through some examples here now. So if you're told, like on numbers 1 through 4, to find the first 6 terms and the 100th term of the explicitly defined sequence, well, that means if it's explicitly defined, they've given you some sort of formula to get each term in the sequence. So, for instance, if we looked at number 4 says that d sub n equals n squared minus 5n. Well, if we need to find the first 6 terms, we simply will plug in n equals 1, 2, 3, 4, 5, and 6. We'll plug each one of those in for n and get what that equals. If we want the 100th term, well then, we're going to plug in 100 for n. And if you do that, you should get -4, -6, -6, -4, 0, I'm sorry, 0.6, I believe is what I wrote down. And then the 100th term is at -9500. No, that doesn't make sense. Positive 9500 must have been what it was. So that's just simply plug it into the formula to get each term. N represents the number of term that you're on. So something to point out and note, that's where the sequence was explicitly defined, where you had some sort of formula where you plug in the number of the term that you're on to get the answer back for that term. If you look at 5 through 10, well, now the question says find the first 4 terms and the 8th term of the recursively defined sequence. When they are recursively defined, well, that means that they use a previous term to tell you what the next term will be. If we look at number 5 talks about, let's see, the setup is you're given a sub 1, which means they're giving you the first term is 8. You're also given a sub n, which means the nth term is going to equal a sub n minus 1, and then there's a comma there, but there shouldn't be. That's a typo. It's just a sub n minus 1 minus 4. And that's for n being greater than or equal to 2. So here's the situation. This is a recursively defined sequence because they give a previous term to define another term. Now what this a sub n minus 1 means, well, if you're looking at the a sub nth term, the a sub n minus 1th term is the term right before it. So what this is saying is, to get the next term, you take the previous term and subtract 4 from it. Since you're adding or subtracting to get the next term, that's an arithmetic sequence. Look back at your notes that you took on arithmetic sequence, and this is what you know. It can be written in this form. It has some constant d, and in the case of the one that we're talking about, that's -4. That's called the common difference. Each term in an arithmetic sequence can be obtained recursively from its preceding term by adding d, and then it's written out like this. So that's what we'll talk about for now. So with that said, we know it's arithmetics, and we want to know the first 4 terms. Well, the first term is given as 8. The first term was given as 8. And then we just plug 8 into this formula. 8 minus 4 is 4. Then we plug 4 back in. 4 minus 4 is 0. Plug 0 back in. 0 minus 4 is -4. And then we also are supposed to find the 8th term. Well, if you have an arithmetic sequence and you want to find the nth term, what you can do is you can take the first term plus the n minus 1th term, so the number of the term right before the one you want. So if we want the 8th term, the n minus 1th term would be 7. If we want the 8th term, then we want 8 minus 1 is 7, and we take that times the common difference, which is -4, equals -20, which tells us -20 would be the 8th term. That's what we're trying to find, the 8th term. So basically, the formula you want to write down for that is, if I have an arithmetic sequence and I want to find the nth term, I take a sub 1 plus the number n minus 1 times that common difference. And that's going to equal that nth term that you're looking for. That's a big P. Make sure you write that down. I'll just mention this quickly about number 6. It's the same setup. You should be able to recognize from this formula that you have an arithmetic sequence. You're adding 10 each time. The common difference is a +10. The only difference here is that to find the u sub k plus 1 term, you use u sub k, which basically is another way of saying take the term right before the one you're looking for. K is going to be right before k plus 1, and add 10 to it. Then you have the same setup as you did last time. Now, in an example like number 7, you're not adding or subtracting from the previous term. Notice we have b sub k plus 1 equals 3 times b sub k. So we're still using the previous term, but now we're not adding or subtracting from it. We, again, know the first term. That's 2, but it's a different situation. This is called a geometric sequence. If you look back at your notes, your geometric sequence came in this form. You start with a number, and then you multiply by some value r, and then you take that same number and you multiply by r squared, and so on and so forth. Well, that r term is called the common ratio. When you keep multiplying the previous term by that same number called the common ratio, it's a geometric sequence. It looks like this form. Okay, so we'll go back to that example. So again, in writing out the first 4 terms, I start with the first one given, and then I plug that one in. 3 times 2 would be 6. 6 times 3 would be 18. 18 times 3 would be 54. And then what we need to do is we need to find, again, the 8th term. Well, the little formula you need to know for the geometric sequence is to get the nth term, a sub n, what you do is you take the first term times the second term divided by the first raised to the n minus 1th power. Now that a sub 2 divided by a sub 1, well, that should be the same as the common difference that we were just talking about, or I'm sorry, the common ratio that we're just talking that's involved with the geometric sequence. So if you know that common ratio, that's the number that is this a sub 2 divided by a sub 1. So to get the 8th term, we're going to take 2 times 3 raised to the 8 minus 1, or 7, which equals, I believe it equals 4374. So again, a sub 1, that was 2, that came from, it's the first term. This 3, that's that common ratio. If you weren't given the common ratio, which we basically were right here, if you weren't given that, you just take the second term divided by the first. And then what power do you raise it to? 1 less than the term that you're trying to find. If you look at problems like numbers 9 and 10 where they're defined, we call this being defined recursively, where you're given c sub 1 and you're given c sub 2, this is number 10, and then c sub k equals c sub k minus 2 plus c sub k minus 1. Should have wrote this all out for you ahead of time. And k is greater than or equal to 3 in this case. Basically, if it's defined recursively, that means you're using multiple previous terms to get the new term, and there's not some formula that we have for this general case. What you'll have to do to get to that 8th term is write them out. So at this point, you would end up writing out up to the first term. So how this works is, so the first term is 2, then 3. So this is saying take the term that's 2 terms before the one you want and add it to the term that's 1 right before the one you want, which is saying 2 plus 3 to get the next term, 3 plus 5, 5 plus 8, and so on. And let's see. I think what I did was I combined a couple problems there, numbers 9 and 10 with the 2 and the 3, but the same concept still applies. So this isn't going to match a problem exactly from your homework, but that's how it works. And you'd write it out however far you need to go to get what you're looking for. Numbers 11 through 20, you're asked to determine whether the sequence converges or diverges. If it converges, then give the limit. So on number 11 here, you're given the sequence is 1, 4, 9, 16, dot, dot, dot. So then it goes to n squared, dot, 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 means it goes on forever. But it tells you how to get the n squared. I wouldn't have had to have given that to you. You could have, by looking at this sequence and trying to figure out how those numbers came about, you could have got that n squared, defined it. But either way, what we would do is we would take and we would be looking at the limit as n approaches infinity of that n squared. Well, as n approaches infinity, what's this going to approach? Infinity. It's going to keep getting bigger and bigger. Since that's not a specific number, we say it diverges. On number 12 here, the sequence is 1/2, 1/4, 1/8, 1/16. Well, you probably can see that that's the same as, or that's the same as having 1 over 2 to the nth. And that continues to go on forever. Well, you do the same thing. Take a look at that limit. The limit as n approaches infinity of 1 over 2 to the n. Well, as n gets really, really large, well, what happens when you take 1 divided by an extremely large number, or bigger number? Do you approach a specific number? Yeah, you're going to approach 0, which means we say that it converges. And what does it converge to? It converges to 0. So what I've written up here is number 16. When something's written like this inside this type of brackets, basically it's saying a set of all numbers where when you plug in all numbers for n, or all positive integers generally for n, those are the numbers that we're talking about in this set. So basically what's being asked for number 16 is you're being asked to take the limit as of 2n minus 1 over n plus 1 as n approaches infinity. And now you got to remember back, how do we take a limit of this? Well, remember, if the degree of the polynomial on top is the same as the degree on the polynomial on the bottom, then you take the ratio of leading coefficients, which would be 2 over 1, which means that this sequence converges to 2. That sort of thing. Same type of situation for 15, 17, 18. You're going to do the same type of thing. A little bit different here on number 19. You're given a sub 1 equals 1, a sub n plus 1 equals a sub n plus 3 for all n greater than or equal to 1. Well, you should recognize that's arithmetic, and so you could write out the sequence and you could figure out that. So you'd have 1, 4, 7, 10, and then you would be expected to figure out, well, what does that equal? Or how would I figure out what that's equal to? Well, since you recognize it's arithmetic, go back to your arithmetic notes here and remember that a sub 1 is going to equal n minus 1, or a sub n is going to equal a sub 1 plus n minus 1 times d. Well, knowing that, you can write out the formula. If you plug in 1 for a sub 1, n minus 1 you don't know, but the difference, well, 4 minus 1 is 3, or 7 minus 4 is 3, or 10 minus 7 is 3, which means a sub n is going to equal 3n minus 2. Distribute the 3, combine your like terms. That's what you're looking at. So now with that in mind, you can take and find the limit as n approaches infinity of 3n minus 2. And then you can tell if it converges or diverges. Finish that one out. So I'm running out of time here, but if you go on to the second assignment, number 21, you're told the following sequence is arithmetic. You need to find the common difference, the 10th term, the recursive rule, and the explicit rule. Well, it's quite simple to do all that. The common difference, you just subtract one term, or the previous term from a current term, like 10 minus 6, 14 minus 10, and so on. So right away, the common difference you would know is 4. And then what's the 10th term? Well, so you're looking for a sub 10. You know that needs to equal 6 plus 10, that's the term we want, minus 1, times the common difference. Just multiply that out and you get the answer. 42. That's a 4 and that's a 2. So that's part A. That's part B. Part C says find a recursive rule. Well, you basically just a sub n is going to equal the previous term, a sub n minus 1, plus 4, that common difference. That's the recursive rule, and then you need to mention where you start, and you need to mention where n starts also. N would be greater than or equal to 2, since the nth term is what you want, if you did anything less, then 2 minus 1 would give you a term left where n is less than 0 and or equal to 0, and we don't want that. So the last part, D, says find the explicit rule for the nth term. Well, that's using that formula again. So a sub n would equal 6 plus n minus 1 times your difference, which is 4. And then you multiply that out, expand, combine your like terms, and you get 4n plus 2 in this case. So that's what we're looking for 21 through 24. 25 through 28, you're doing the same thing, only for the geometric sequences. So I would do those the same way. Just to verbally help you with ones like 29, 30, and so on. Like on 29, you're given the fifth and you're given the fourth and seventh terms. So set up equations for each of those. For 29, if you're given the fourth term is negative 8, so negative 8 would need to equal a sub 1 plus 3, because n minus 1 is 3 in this case if it's the fourth term, b. And then for a sub 7, you're told or the seventh term, that's 4. That needs to equal the first term plus, well, 7 minus 1 is 6, so 6d. Now you have two equations with two unknowns. Solve for d and finish out those types of problems in that way. That's all I have time to discuss right now. Hopefully this video helps you out. Feel free to tweet me some questions and work together in class. Help each other out.